Look into how to use this Web3 programmatically to take our smart contract, deploy it, and interact with the same. Let's get into it. Now, for using Web3, I need a few things. So till now, all we have been seeing about is using this remix to write a smart contract, etc. But in this scenario, what we are going to do is use the Visual Studio Code. If you remember, we installed this Visual Studio Code in our systems, and this can be used to open up any new projects, etc. Right? So if I get into this, and I go to any folder, I've created the folder called as web3 demo, which you can normally create in your Windows or Mac by the normal things. Just open the folder by going to file, open, right, or add folder to workspace. This is going to add the folder in which you can right click and go to new file, right. So I created a add.sol, which is a very basic smart contract, right. Let me just show you first add.sol. Right, I've used pragma solidity, the same things which we wrote in remix I'm using here, right. And this contract is called as add, which has three numbers, num1, num2, num3. What I'm doing is doing a sum of two integers and adding it to num3. If I get sum, what's going to happen is it's going to return something called as num3, right. So that is the thing. And yeah, of course, num1 and num2 is not used at all anywhere. Right, I'm just getting two arguments and adding it to num3. You can change it however you want, or let me change it now itself, right. I'll anyway give you this code, so you'll be able to go through this. So I'll call it sum, and let this be num1 and num2 that is coming as input, and return sum, right. So it does the same thing, gets two inputs, does a sum, and if you go to get sum, it will return the value of the sum variable, right. So that's my add.sol contract. Okay, now what I'm going to do is write a JavaScript file. Okay, as you know, any website uses JavaScript and HTML and CSS, so that's how it is styled, and that is how you execute something from a website, correct. So to do this interaction, we need three things. One is the Solidity compiler, right. Second is a file system. So what is this file system? Is it helps you to read and write files to your computer, right. So you can write a text file into your system using a JavaScript program, right. So that is possible using the file system. Okay, also you need something called as Ganache, which is the local blockchain, right. So we'll install this, and more about this in the next section, but for using this web3, let's install this to see how it works alone, right. And of course you need something called as the web3 also. We just saw what is this web3, why it is used. So we need the web3 interface to do the deployment process, talk to the contract, etc. Why we are doing this is because you need to go through the difficult way of deploying a contract first. Only then, when we get into something called as truffle suit and see how easy it is to deploy the contract to the blockchain, you will find the difference and you will appreciate the value of truffle framework, right. So this code is going to be JavaScript heavy. If someone is happy and comfortable with JavaScript, you can go ahead. If you're not comfortable, just look at the code, understand what it is doing in the backend, so that you'll get to understand ABI, bytecode, all the concepts, right. Then you can try out on your own. If not, there is a truffle suit, that is a framework used to create smart contracts and deploy it, etc., right. So we'll get into that, and that will be a pretty easy process to do, right. So this is important for you to put into work what all you have learned till now as a theoretical concept, correct. So that's the reason why we are getting into this. Yeah, let's install this one by one, right. But before that, since Ganache has to be installed from a website, let me get into that first and install it. The installation process is pretty simple for your Windows, Mac, or Linux, anything. You can just install, just see what is happening here, and you'll be able to get the concept. Yeah, to install this Ganache, you need to go to trufflesuite.com, trufflesuite.com, and if you look at the tools, the suite, you'll have this Ganache, right. This is what we want, and go into that page. Automatically it will detect your OS which you are using, and you can download this. Once you download a deb file or a exe file, you will be able to install as usual, right? And you can get this Ganache working. So it will be installed as an application within your system, and when you open this application from your, let's say, this is my application list, right? In this I have Ganache here, right? Similarly in Windows you can go to applications and use this also, right? So once you open this up, this Ganache, it will give you quick start. Just click on this quick start, because all we need is a local blockchain to run this JavaScript file, right? So in Remix we had this JavaScript VM which we could have used to deploy the contract, etc. Here also it's a similar thing, multiple accounts with 100 ether, this is the mnemonic and everything. More we'll look at, but here one thing to notice is HTTP localhost 7545. This is important because using this interface, using this port only, we are going to connect our JS file with the Ganache blockchain. Okay, this is also a simulation just like your Remix IDE JavaScript VM, right? So it's gonna work very similarly. So this is done, right? This Ganache is installed and done. Remember 7545, right? We'll just be using this URL here in the JavaScript file. First thing we need to look at is our Solidity compiler, right? So what I'm going to do is install this JavaScript and run it using the Node environment that I have installed. So already we would have installed the Node.js and npm and things like that, right? So we are going to look at how to run this JavaScript file, and the best way to run this is using Node.js itself, in my opinion, and that's the reason I'm going to use Node.js to all this stuff. So what I need to do is first install solc, right? So I'll see solc equal to require solc. So this is how any Node.js application imports a particular package. We saw libraries in the form of packages, pre-written code, etc. Similarly, solc is already pre-written, and we need to install this using npm install, which we'll do in some time, right? So once you install, we are going to require this solc package like this one. First we'll write the code, then we'll do the installation and running and everything, right? Similarly, file system is called as fs. Fs stands for file system. You will say require fs. Why this file system is required is because my add.sol is a separate file, right? So this file has to be called by call.js, right? For that I need a file system to read the contents of the file. That's why I'm taking file system, right? Ganache is already done, and web3 works like capital web3 equal to require web3. So this is also a, how do you call it, a package which needs to be installed, right? So now we'll get into the actual program. I'll tell you why this is a capital web3. You can name it anything you want, but I've chosen this capital W because of a reason, right? So going to this, first thing we need to do is set up a HTTP provider for the web3, right? How can I do that is by saying small web3. Okay, this is what I'm going to use throughout my program, but just to import it I use capital. Okay, here I can say new web3, which means it is going to set up a new web3 connection for me, right? Within this again it will be new web3, remember capitals, right? Dot providers, because there are multiple providers like your MetaMask, like your MyEther wallet, and you can also create your own provider if you are a full node, etc., right? So new web3 dot providers dot http provider, right? Why http? Because my Ganache is in http 127.0.0.1 7545, right? So here I will give 0.1 also. So this is how you set up a connection with your Ganache blockchain, right? So we just installed it, and this is how you access that local blockchain simulation, right? That way. If you want to connect with the mainnet, or if you want to connect with your Robston testnet, etc., you will change this link. Okay, so those will be available at an API endpoint. You will connect with that, etc. So don't worry if you don't understand what is going on. Just get how this backend works. This is hardcore stuff for you to understand as a programmer, right? Only if you understand this, your clarity of thought will be coming up for in Solidity, right? This is the web3 setup that we have done. Next step, what we are going to do is read the contents of the file of the smart contract. Let's say smart contract, correct? So for this, what I need to do is file content, right, is equal to, I'm going to use the fs package, correct? So fs dot read file sync. Okay, so this is going to read the contents of the file which I'm going to give now, right? Add.sol. I can just give the name because it is in the same folder. If it is in a different folder, I have to use dot dot or dot and things like that, right? Now I want to convert this into a string because usually JavaScript does not know it is a string or what, right? It is going to be in a weird format when it reads the file, right? So just read it and convert that to a string so that it's easy for me, right? So what I can do is I can just do a console.log, right, and show you the file content, what has been read. Okay, so while running, this will actually be displayed so that we can look at what is this file content. Okay, so that is how you read the contents of the file. Great. Now next thing is I want to create an input structure for my Solidity compiler, right? So the first thing that we need to do is take this contents. We have read the content as a string. Now we are going to supply this as an input to the Solidity compiler. You know that whenever we want to deploy, we need the Solidity compiler. We'll give the input, the contract itself, and it will give two outputs, ABI and this thing, right? So that's the exact step we are going to do now. But the problem is this Solidity compiler called as solc expects the input in a particular format. Okay, so the format I have taken from their official documentation, right? And the format is this. Okay, so I don't want to confuse you by writing all of this myself. So let me just take this. Now this is the format we have to supply to the solc compiler. Okay, we cannot just give that the file content. Okay, so this input, we are saying language is Solidity. What is the source? Add.sol. What is the content of that source? Is file content. We have already read that. Okay, then comes settings, output, where it should be, all of that. I'm just giving star because I want all the default settings for the output. Okay, this is how you create a input structure for my compiler. Okay, again at the end, once we write the entire program, I'll take you through what has been going on, right? So you can get a good revision also. Now since we have created the input, right, the next step is to create the output. You have to input this into the solc compiler. Compiler is going to give an output, correct? So I'll just say var output. Var is the variable, constant variable. You'll use this as a var, right, keyword. So var output is equal to json dot parse, right? Within this solc dot compile, okay, json dot stringify, right, the input. Okay, so this is how you take a string input, okay, convert it into JSON, send it to solc, it will compile it, and then you will again convert it into JSON so that we can use it easily. Okay, it will come as an object in json.parse, json.stringify, etc. If you know JavaScript, this is how JavaScript uses JSON data, etc. Right? So that is how output is. What I'll do is I'll also console log this, okay, so that you will be able to see the output for yourself, right? It will be a large output, but still we can make sense out of it. Now once we have got this output is not going to remain a very readable format for us, but this output is also going to have multiple other details like the opcodes and things like that. What we ideally need is only the bytecode to deploy into the contract, right? Deploy into the blockchain. Also the ABI, the abstract binary interface, right? So those two have a specific way in which you can get it from that. So I'll take the output. Within that there is a contracts object, right? Within that you'll go to add.sol because that's the file name. Add is the name of the contract that we have written dot ABI, right? And then that will give you the ABI, and then you have the bytecode output contracts add.sol.add. Within that you'll have evm.bytecode.object. So this will give you the bytecode that is compiled by the Solidity compiler. Okay, so what we can do is I'll console.log this also, called as the bytecode first, right, comma bytecode, and I'll say console.log ABI, comma API. This is the API, right? So with this, we'll be able to see the output of the bytecode and the ABI in our Node.js terminal whenever we are running this. Okay, so it is good if you think these are sounding very difficult, looking very difficult to do, right? Nobody expects you to remember all of this code for sure, right? So yeah, you can use this as a template itself whenever you want to use this web3 interaction. Why I am showing you this is so that you understand the backend, how it works, correct? Now at this juncture, we are going to create the contract instance and deploy it, right? First thing for that, we'll do a contract is equal to new web3 dot contract dot web3 dot eth dot contract, and you have to give the ABI we found as an input to this, right? So once you do this, what's going to happen is web3 has a method called as eth. Okay, so this eth is going to connect you to this web3, and it says that you are going to connect with the Ethereum blockchain and smart contract is in Ethereum, etc., right? And then you will say dot contract. What is the contract? How is the structure of the contract? Is using the ABI, right? If you remember, ABI contains all the functions that we create, its inputs, outputs, view, payable, all of these things, right? So that's the way to create a new contract. Next step after giving the contract ABI is to go and do web3 dot eth dot get accounts, right? So if you do get accounts, what is going to happen is this get accounts will connect with the current provider web3, right? For example, you have connected with the Ganache, right? So this has multiple accounts, so it's going to connect with 8515 2e73 and all of these things. Okay, it will get all these accounts as an array. Okay, so you will say get accounts, and within this you are gonna do dot, then it is gonna give all the accounts. I'll pass it in. Okay, so this is how you write ES6 components in JavaScript if you have gone through. So within this, I want to make use of these accounts, right? So I'll just do a console log of these accounts, so it will be displayed in the output also, right? Accounts, comma accounts that we have taken, right? Then I just need one account to deploy the contract, right? So let me create a var, right, or let me create it outside var default account, let's say. Okay, so this default account is going to contain the first account. How do you take the first account from an array? You will do accounts of 0, correct? Let me console log that also. All of it will be clear to you whenever we are seeing the output in node. Okay, so this will be the default account itself. Okay, so that's how I'm displaying the accounts array, and the first account as default account I'm setting up. Okay, now is the time to deploy the contract that you have been waiting for, right? So to deploy this contract, you will again say contract, right? So contract is what? This ABI and things like that, right? So contract dot deploy. What do you deploy into the blockchain? You will deploy the bytecode, correct? So I'll say contract dot deploy. What is the data you need to deploy? The bytecode, right? Dot send, because this is a send transaction. You are actually doing a transaction in the blockchain. In the beginning, we would have seen two types of calls that can be done to the smart contract: one writing to the smart contract and one reading from the smart contract, right? So this is the first type where you write a transaction, correct? So within this, what we need to give is, so just like how we did this data bytecode right here, we will do open flower bracket, say from default account. Why is this from default account required? Because this is the account from which the gas fee will be deducted. Okay, so that is the concept of contract.deploy data bytecode.send from this, right? So this will deploy the contract. One thing to note here is that once this contract has been deployed, the blockchain is going to give you back some information, right? This will be a transaction. It is going to show you the transaction, and then it will also give you events, the contract address, everything, right? In Remix, we saw in the logs, we'll get a lot of information whenever you are deploying a contract. That information can be obtained using .on method. For that, what you need to do is do .on, okay, open bracket, close bracket. If it is a receipt that is going to be given by the blockchain, then we'll do a arrow mark function, right? The receipt will be the callback given by the contract, okay? On receipt, pass it in, and within this I can say console.log, okay, contract address is comma receipt.contract address, right? So that is how you get the receipt which contains the contract address from the blockchain itself. And don't worry, we are not going to stop here. This is an even more complex thing to do, right? So we'll do .then. .then is a promise provided by the JavaScript functionality, right? So .then, what am I going to do is take an input, okay, and I'm going to do something with that input. What is the input I need? I need the contract itself. What is the deployed contract? I need the contract instance, right? The address of the contract, correct? Now within the then, I can open this and say call it some contract, or let's say add contract, because it's an addition that we are doing. Arrow mark function again, and within this I'll be able to call and talk to the contract from here. Okay, so for that, what am I going to do is use the call sum and everything. Okay, now what am I going to do is to first see the sum. Okay, if you go to add.sol, you can see some variable. First it will be 0, correct? So if I see it as 0, it's going to be uh, evident that nothing has been added into the sum. The default is 0, right? So first it is going to show 0, then I'll call sum. Okay, this sum function is going to add two numbers, whatever we provide, and then again I'll get sum. Okay, first do get sum, it should show 0. Second, do a sum. If we do 2 comma 5, it's going to add both and give again. And when I call get sum, it's going to give 7, right? That is how I'm going to make sure these things work well. Okay, so go back to call.js. Here you can say add contract dot methods. Functions are also called as methods, right? So here I'm going to do get sum first. Remember, get sum is the function which will return the sum. Okay, first I want to show you 0, right? That way. And it's a view function, which means it's not going to do any transaction, correct? So I'll say get sum dot call, right? So once this comes, it's going to give a result to me. Yeah, I'll take that result using a arrow function again, correct? But before that, within get sum, if you want to send some arguments to the function and all, you will give here only. Okay, that we'll see in the sum function anyway. Now callbacks are usually written this right, like this, right? So you'll say error comma sum, let's call it. This will be given inside the function. This will be given by the blockchain. So sum is what will be returned, right? So I'll take it and say console.log, okay, initial sum, okay, and then call it sum, right? That is going to give me the initial sum. And I want to do the same thing for final sum also. So let me do it here. Instead of initial, final, let's call it. Okay, it's the same process, and in between this I'm going to call the sum function with 2 arguments, correct? So that's what is the final step we need to do. Then we can proceed with the execution of this program anyway. Now In order to do a transaction, right, you just read the information from here, but here we need to do a transaction, right? For that you will say add contract dot methods dot sum. Okay, remember that sum is a capital S. Okay, so I'm just saying the same sum. Inside this I have to pass arguments. Here it is expecting two arguments, right? num1 and num2. We have to do that two things. So let me pass 2 comma 5 as I discussed, right? Dot, this will be a send function. Why is it a send function? Because we are doing a transaction, correct? So within this, as usual, I'm going to give from which account. So I'll say default account, correct? So this is how you will call that. The problem is this is a call that it is going to take time also, right? So what I want to do is I want this get sum to be called once this is complete only, right? It makes no sense to do a transaction before that completes itself you call the sum, right? So we have to wait till this transaction gets complete. So what we need to do here is put a dot then. Okay, so once you do a dot then, what's going to happen is it will wait for this to be complete, then perform whatever we are saying. Okay, so within dot then I can give this entire get sum. So final sum is going to be displayed here, correct? So that is the concept of how I'm going to show you initial sum, contract and this thing, right? So that is how it will all work. Let me just remove all the additional spaces, and now we'll once go through what all we have done. Okay, I know it's a lot. I know it will be complex for the first time, right? So nobody is going to ask you to memorize this entire thing or write this complex an application. To make this life easier, we have something called as truffle, right? Even production level applications use only truffle, but for any developer getting into Ethereum, this is very important to understand how it works. Okay, what can truffle do? It can just do it in the backend, right? But as a developer, you need to understand all of that. So even if you do not know how to write this code, just understand the logical flow, right? So we are taking Solidity compiler, file system and web3. Web3 is used to connect to any blockchain. In this case, I am connected to the Ganache local blockchain, right? I have read the file and I have inputted that into the Solidity compiler. So the compiler is going to give me the ABI and bytecode, right? Using the ABI and the bytecode, where is my bytecode? Bytecode. I am deploying this contract into the blockchain. Once I deploy, I'll get the contract address, right? This add contract instance, I can call all the functions within that. So add contract.methods.getSum is the getSum function here, right? Dot sum is the sum function there, right? So once I do this, I'll get all the things required and necessary. This is how we connect to the blockchain, interact with the blockchain by deploying the contract and calling the functions. Okay, so that's the process. So I want to run this in a terminal and show you how this works. Okay, let me just save this file. I hope there are no errors. Let's run it. See if there are any errors. Of course, I'm a human being. I can make errors, of course, right? So just in VS Code, the advantage is that within VS Code itself, we have the terminal. Okay, you can just right click and open terminal. Yeah, open an integrated terminal. Okay, in Windows also it opens the command prompt for you. Okay, you can just run it here itself, right? So here I'm gonna do first npm install, but let me show you. I have to run node call.js. Okay, call.js is the file name and node is in the environment in which I'm going to run it. So once you get node right, so it is going to throw you errors. I'm not able to find sol c, okay, because we wanted sol c, fs and web3, right? So we have to install that before running our program. Okay, so we'll just say clear. Okay, npm install. Okay, that's how you install packages using node package manager. Okay, so you will say sol c and then you will say fs and so web3, right? So all of this is what we need to install in our project. So if you just do this, it's going to take some time to install, right? We'll wait till then and I'll show you how the installation ends and what is the message you will get at the end of the installation of all of these three packages. Okay, perfect. I can see that all of the packages has been installed, right? So it took a good amount of time for me. I'm sure it will take some time for you also, right? So here you can see FSS at 0.0.1 is been added. Web3 1.2.11 is added, and Solc 0.7.0 has been added into my package, right? It doesn't matter. We have written it in 0.6 point something, this contract, but it's okay. It's a very simple contract, so not a lot of differences with 0.7 also, right? So here now I can run node call.js and hope it works, right? So before that, what I'll do is let me clear the page, right? Now I'll do node call.js. We just open this up in a full screen so that we can see it easily, right? Okay, there is a error which talks about, what is it? What is the error we are getting? Cannot find module solc again. Okay, that's interesting. Why is that the case? Solc has been installed already. Let me try installing it again, maybe, right? And here it is saying formatted message, nightly builds are considered, different compiler version. Oh, it's not working and the compiler version also. Okay, fine, that's good, that's good. Okay, so what we need to do to solve this is, okay, you might also face the same issue, right? You can do two things. One, you can change the compiler version here, okay, which is an easy method to do. Otherwise, you can say npm install web3, not web3, solc at the rate of 0.6.4, right? So this is also possible. Only thing is, if you install it as a package, right, you have to change the default package for solc and things like that. So instead of going with this method, let me just change this to 7.0, because that's what is the solidity compiler that we have been added. So just say this, now call node call.js. We'll solve this one by one, because I know that you will also face the same issues, right, without all the packages and things like that, right? Perfect. Now I've got the output, but there is a problem again. Let's see what it is, right? So call.js, that's fine. Now it is saying the output. Okay, I've got the output, and it says contract equal to new web3.eth.contract is not a constructor. Okay, good. Then we need to solve this problem. Where is it? It is in contract equal to new web3.eth.contract of ABI. Okay. What could be the issue? Okay. I just made a small mistake here. It should be capital C, right? That's the small problem. Anyway, so go back to the terminal and clear this off. Node call.js again. Hope it all works today, right? So node call.js, you can see it is running slowly. Let's hope everything works. Not really, we got an error again. That's fine. VLM exception while processing transaction out of gas. Oh, seriously. Okay, that's fine. Okay, that's good. So how do I solve the problem of gas is something that we need to look at. Okay, let's see. In your program, go back to this, and wherever I'm sending the transaction, right, I can give something called as gas also, right? Let me try giving that, right? Yeah, what you can do is you can do a comma, gas is to 470k, right? I just wrote this like go to gas is to 470k. You can give any amount here, but I've seen this on the example, so we can give the same thing. Why not? If it requires more gas, we can give that also, not an issue, right? So now let's run this and see what happens. Node call.js. Hope everything works well now, because I think I've cleared all of the problems. Okay, so it is giving me all the address and contract address. Okay, so it's giving me default account and also the contract address. What is the problem now? Then it's not working, which means on receipt. Okay. Oh my god. On is getting over here only. That is a problem. So I have to actually close the on. Only then I have to open this itself. Yeah. Now this should work hopefully. Right. What I have done is, I mean, dot on, dot then. It should be that way. Okay. If you save, it's gonna reformat and say dot deploy, dot send, dot on, dot then. Okay. That is the way it should be formatted. Right. So that was another problem. I'm sure you would also got that error. That's fine. As long as you're able to debug the error one by one, you'll be able to run this. So as I told you, this is a complex application. It's not so easy to understand, right? But yes, we will look into this, of course. Okay. Fine then. So I've got add contracts dot methods. It has sent also and give dot then. It's not working because it is not sending and waiting for it. I can see the initial sum is 0 and final sum is also 0. Okay. So in these scenarios, whenever dot then is not working, I'll go back to the usual callback. Okay. And here, let me do a callback. So instead of then, I'll call this on top itself. Okay. So that's fine. Anyway, I'll give you this entire program, so you don't need to worry about how can you run this, write this with all the differences that I'm doing and things like that. That's fine. This is how you will write a program, of course. Okay, always this is the case, no other go. Oh, perfect. So now I've got initial sum is 0 and final sum is 7, which means my interaction with the smart contract is working well. Okay. So we'll go through this entire thing. Okay. First thing I wanted to console log the file content. Okay. What is the file content? Something that was read from the add.sol. What is showing here? It's pragma solidity 0.7.0 contract add. What is this? This is the contents of this file, right? It has just read the contents of the file. Okay. And then output has been console logged also. So once you enter the contents of the file into the compiler, it's going to give you the output. Okay, let's look at the output. So this is the output. So here it says contracts add.sol. Within that add and within that there is a huge object. Okay, now these are the warnings that we have. That's fine, not an issue. SPDX license is something that we need to add for production level applications, right? So within this contracts, that means what? Output dot contracts dot add dot sol, right? This is the add dot sol, and add, this is the add. We have ABI, and then we have EVM bytecode object also. We have taken that out, separated and given it in separate variables. So first we are going to display the bytecode. Where is it? You can see my bytecode is here. So this is the entire bytecode of my contract I have written. Okay, this is the one that is deployed to the blockchain. Then comes ABI, abstract binary interface. As you know, ABI gives you the name of the contract and no. ABI has inputs. I mean, these are separate objects. Okay, let me do ABI dot, right, ABI of 0 dot inputs, correct? Because it's an array, I need to give an object, right? Inputs, state mutability non-payable. Okay. Fine. This is the sum. Okay, this is the sum function. It is just given. It is not an object and all, right? State mutability non-payable function, and then comes get sum, right? This is a view function, etc. So only two functions are there. So it is giving only two functions in the ABI also. Okay. So once this is also done, you see contract and all of these things within the web3.get accounts. I'm getting all the accounts and displaying that, right? Accounts is this. So if you look at this accounts, it's an array. Yeah. The first one is 8515-2E73A08C. What are these accounts? Where is it reading it from? It is going to Ganache connecting 8515-2E73A08C. That is what it is taking, right? And of course, as I told you, default account will be the accounts of 0, right? So this is the default account. Okay. That is also being displayed to us as default account, right? So once this is done, we are going to look at the contract and deploy it, right? So you have deployed the bytecode as data from the default account. Why this is significant is because you can see here is where the gas got deducted, right? Balance was 100, now it is 99.99. Some small amount has been deducted for the gas price. Okay, so gas is gone. Then on receipt, we were displaying the contract address, correct? So this is the contract address where my contract has been deployed in the smart contract. Okay. Also, you can see the transaction within Ganache itself. You can say contract call, contract creation. So this is FD3F, right? And from address, contract address. Yeah. 4B02 is supposed to be my contract address. Yeah, 4B02. Yeah. This is how my transaction has happened. And then comes initial sum. So beginning, what is the sum of the sum variable value? It is 0. Then comes sum of 2 comma 5 I am doing, which means it is supposed to do 2 and 5, add it and save it in the sum, right? And then when I call sum again after this is done, it is going to give me the final sum as 7, right? So let's change it to 12 comma 5 and see what happens. Final time, right? Node call.js, it's gonna execute all of these things, and it says 0 and 17, right? So why didn't it add with 5 and then these things? Is because we are creating a new contract, right? There is a new contract address here. It's not the old contract we are contacting. Yeah. So that is how you will use JavaScript and Web3 to connect with the blockchain. This is the complex method. This is the roundabout method. This is the difficult method that I have taught you, because you need to understand what happens within this Web3 and how difficult it is. What are the methodologies that happen to deploy a contract, right? I'll give you this code, of course, but the next section, when we are getting into Truffle, you will understand how easy Truffle is making our lives when deploying a contract and calling the functions of a contract, etc. It's going to be pretty easy compared to this, of course, and I hope you have gone through this. Go through the same things again, and I'm sure you'll be able to understand the logic with which Web3 and calling the contracts work. Okay, make sure you understand each and uh, every step that we have done here, so that you get a pretty good understanding of what really happens when you write a contract and deploy it. What is the difference between send and call, etc. Okay, so in the next section we'll see again.